the outer layer, CDO, is 1 over rho E cube integration from 0 to let's say infinity of tau partial u partial y dy. Okay. And now if we just look at the outer layer, and in the outer layer, remember we start from a US, goes all the way to UE. And the correction we add to the outer layer as a function of y from 0 to delta 99 is a function like that, right? So we already subtracted the log layer part, subtracted the inner layer part. So the addition we have is just that. So here we use the assumption of a constant eddy viscosity. So we use the fact that we think of the eddy viscosity where tau is equal to mu turbulent times partial u partial y, and actually we don't assume a constant eddy viscosity, we assume a constant mixing length. So assume mu t is equal to a constant mixing length L squared times the magnitude of du dy, and that L is equal to about 0.09 times the thickness of the boundary layer. And this we can basically, this is as a result of tuning with respect to measurement data. All right. So with that, we plug it into the tau and we can integrate. So my CDO is equal to the non-dimensionalizing factor. We have this L squared, so L is a constant, so we can just write it as L squared times mu t times du dy to the third power dy, right? And then by plugging the fact that this modification, I mean this u is the outer layer u, so it's already subtracted by the inner layer. So this u is actually equal to us plus ue minus us, so that's the correction, times sine square of y divided by delta times half pi. Okay, so working it through, you can basically figure out that the derivative is now proportional to ue minus us, right? So what you get is you can pull that out of this integral. So what you get is ue minus us cubed divided by ue cubed. So that comes oh, okay, sorry, I think there is also a row here and a row here that has to cancel with this row. So we have the ratio of the third power here, and times a constant. I think the constant turns out to be pi square over 16, so kappa. Okay, so the outer dissipation coefficient is a function of the ratio of ue and us, right? Because you can write this as 1 minus us over ue to the third power, and but it is independent of the skin friction coefficient. So that is times a constant kappa pi square over 16.